Today we're doing FRQ topic 2. This is modeling a non-periodic context. Topic 3 will be modeling a periodic context. Topic 2, a non-periodic context, is always with a calculator. So this will be number 2 on the exam. So you're going to be given data values for some situation. These might be in a list or in a table or just verbally. Okay. They will also give you a general equation that models the situation that's being described. The equation can be anything. Part A is always going to have you determine the exact equation using the information given. You're going to be finding the values of some constants, and that'll all take place in Part A. Part B involves the average rate of change. They will always ask you to find the average rate of change in the first part of Part B. In Part 2, you're going to be using the average rate of change you found in Part 1 somehow. They will tell you how to use it. I'll let you read through that on your own. Part 3 of Part B, they will ask you usually something about the error. Okay? So parts 2 and 3 here, those are usually the hardest part of this FRQ. Okay? In part 3, they almost always want you to say, use the concavity of the graph. Okay? And then there's Part C. Part C can be anything. So be prepared to answer just any questions using your head. Okay? If you're asked to find the domain or range, use good algebra and use your calculator to help you. These are with the calculator problems. Alrighty, they might ask you something about long-term behavior of your function. Don't be thrown off by different notation. They like to use some different notation in these problems. So I picked a couple from the worksheet that I made for you guys. The first one that I'm going to do with you is actually number 4. Okay. A biologist examines the population of bison in Yellowstone National Park. In 1902, which we are going to say is time 0, the bison population is 24. In 1950, that would be time is 48, there were 2,400 bison. And then in 2020, that's time t is equal to 122, there were 4,775 bison. The number of bison in Yellowstone, in the Yellowstone population at time t years since 1902 can be modeled by the logistic function. This is called the logistic function. This will be fixed on yours. That should say where A, B, and C are constants. Okay. Part A, use the given data to write 3 equations that can be used to find the constants A, B, and C in the expression for B of t, and then find A, B, and C. So they gave us 3 data points here. Time 0, time 48, time 122. Those are going to create our 3 equations. So in part A here, these will be separated for you. You won't have to separate these, but in part A, and it'll say part A. It'll say write your answer for part A here, and you'll do that. Okay. I'm going to first do the equation when time is 0. So at time 0, I'm putting 0 in for t. A, B, and C will stay A, B, and C, but I'm going to put 0 in for t. So that's going to give me c over 1 plus a e to the 0 times b will just be 0. And they tell me that that is equal to 24 because there were 24 bison at time 0. Next up, go to the next data value. t is equal to 48, there are 2,400, so I'm putting t is 48 in. So c over 1 plus a e to the negative b times t. So negative 48b. And that is equal to 2,400. The last equation will be when t is 122. They tell me that t is equal to 122. There are 4,775 bison, so that creates this equation. AE to the negative 122b is equal to 4775. Those are my three equations. That got me 1 point. That's the first part of part A. Now for part 2, we're finding A, B, and C. Now, we could do this by hand, but it would take a little time. I'm not going to do that because our calculator has the stat feature that we can utilize. So I'm going to go to stat. We're editing what's there. I'm going to clear out or delete what's there. Sorry. Okay. So I'm putting in the data that they gave me. They gave me times 0, 48, and 122. At time 0, there were 24 bison. At time 48, there were 2,400 bison. And at time 122, there were 4,775 bison. Don't forget to hit enter on each of those. Double check and make sure that those are correct, because if they're not, all of your answers are going to be wrong. So I have my data in, so I'm going to go back to stat, go over to calc, and the logistic function is down below. Remember, this little arrow right here means that there are more below. So go down. There's exponential regression. There's power regression. There's logistic regression. And we know it's logistic. They told us it was logistic. Okay? It automatically populates L1 and L2. We can leave the frequency list blank, and we are going to store the regression equation in for Y1. So alpha F4 Y1. Okay? Go down to calculate and hit enter. It gives us the values of A, B, and C. So A is equal to 198.014. We have to give at least 3 digits after the decimal point. B is 0.1103, at least 3 digits after the decimal point. And C is 4776.340, at least 3 digits after the decimal point. I keep repeating that because I don't want you to forget it. You have to do that, okay? Now, in for Y1 are the unrounded versions of A, B, and C, which we want. We always want the unrounded versions. So when you're using your calculator, you might write down only 3 digits after the decimal point, but you are using all of the digits after the decimal point. Because in every calculation, your final answer has to be correct to 3 digits after the decimal point. If you round too early, you might not get that. You might be getting an error, more than what's going to give you credit. Okay, so we have full credit for part A. On to part B. That was two points, 2 of the 6 possible points for this FRQ. Now for part B. Use the given data to find the average rate of change of the number of bison in the park in bison per year from time 48 to time 122 years. Express your answer as a decimal approximation. Show the computations that lead to your answer. Average rate of change. Average rate of change is always change in the function, in this case b, divided by change in the independent variable, in this case t. So they want B, and we want it from time 48 to 122. So B of 122 minus B of 48 divided by 122 minus 48. B of 122, they already told us that that was 4775. B of 48, they told us was 2400. And now we go back to our calculator and find that out. So I'm going to, oh shoot, I just deleted accidentally my regression equation in for y1. So I just put it back real quickly. So now it's back. Good. I'm going to second quit, and I'm going to type this in. So it's a fraction. I might use my fraction template or use parentheses around top and bottom. 4775 minus 2400. By the way, the fraction template is here under F1. So alpha F1 always gets you that fraction template. Now that gave me a fraction, and we need it to be a decimal. So all I have to do is come up, put a decimal point after one of these numbers, and it will automatically change that to a decimal. Okay, so this is 32.0945. At least 3 digits after the decimal point have to be showing. Okay, so that was our average rate of change. That was worth a point. So we already have half of the points possible for this FRQ. Part 2. Use B of 48. Okay, B of 48, that was what they gave us. That was our 2400 bison. Use B of 48 and the average rate of change found in part 1 to estimate B of 98, the number of bison in the park in the year 2000. Round your answer to the nearest whole number. So this time we are not going to do the 3 digits after the decimal point. Okay, so let's see. Okay, so we want to estimate B of 98 using our average rate of change. They told us to we're also using the number of bison at when time is 48. We're also using that. So that's how many bison were there at time 48. We're adding to that the average rate of change times the change in the time. You guys, this is point slope form. This is actually y1 minus y2 is equal to the slope times x, I should say y2 minus y1, x2 minus x1. Change in x, change in y. All I did was move the y to the other side. But it makes sense to me. If you're using the average rate of change, there's your starting, and this is what's being added. This is the number of bison per year, and this is how many years in between the two times. Okay, so B of 48 is our 2400. 98 minus 48 is 50, but if you're unsure of that, and your brain might be tired at this point in the game, so you might just want to let your calculator do that. Now we're going to go to our calculator. So I still have my starting point of 2400. I'm adding, remember, don't round, don't write this in. We're going to use the entire value. So I go scroll up, hit enter, times our 50. And that gives us that value. But they told us to round this to the nearest whole number. So I'm going to say that that is 4,005 bison. Okay, part 3. The average rate of change can be used to estimate the number of bison in the park for years after 2020. Will these estimates, found using the average rate of change, be less than or greater than the actual number of bison in the park? This step right here almost always has to do with concavity. Okay, that third part almost always has to do with concavity. So you guys, this curve, let's take a look at the graph of B, okay? So it's stored in for Y1. What would be a logical window for this? Number of bison. Well, first for times, we're starting at time 0. So I'm going to put 0 for my x min. And we're going to at least time 122. But they want, in part C, they're talking about going beyond 2020. So I'm going to go past 122, maybe to time 250, maybe. Something like that. Remember, this is how frequent you'll see a hash mark on the x-axis. And right now, we're going to see a hash mark. We're going to see 250 hash marks. That is way too many. Let's make it 20 or 30 or even turn it to 0 so you see no hash marks. Y represents the number of bison. It's not going to go below 0, right? In fact, it appears that the number of bison is increasing, starting at 24, right? So we could actually start it at 24, but 0 is fine too. Now this says we're going to go at least to 4,775, right? I'm going to go a little bit past that. I might go to 5,000. I certainly don't want to see 5,000 hash marks on my y-axis. I think I'm going to go by thousands. There's the graph. There is the graph. So we want to know, when we're using the average rate of change to estimate values of bison, will it be less than or greater than this? So I'm going to go in here. I want to find out, we used 48 to 122, right? So we used 2,400 bison to 4,775 bison. So I'm going to come in here. You know what? Yeah, I'll do this. I might put in 2,400 bison for a Y2 and 4,775 bison for Y3. There are those. So remember that the average rate of change, using the average rate of change as an approximation, is using a tangent line. So imagine a tangent line going from this point to this point. Okay? Do you agree that for times between 48 and 122, those approximations will be below the curve? But for times after 122, those approximations will be above the curve. And it's because of the concavity of this curve. That curve is concave down for that stretch. So for times after 2020, our approximation will be greater than the curve. So I need to say something like that. So I'm going to begin with what I know they need to see. The graph of B is concave down. On the interval between t is 48 and t is 122. And after t is 122 as well. Continue my thought over here. So, on that interval, think of that. The curve is concave down. We're using a tangent line. After this point, the tangent line will, not the tangent line, the secant line. After that point, the secant line will be above the actual value. Okay? The secant line between the 2 points. The first point is time is 48, and the y-coordinate is b of 48. The other point is time is 122, and the y-coordinate is b at 122. You could also use the actual values there, 2400 and 4775. So the secant line between those will go above the graph of b after time is 122. Okay, so our estimates will be greater than the actual number of bison. Okay. They are looking for you to use the conclusion of involving concavity. Okay. So that was a little bit hard. I get that. But there you go. Part C, according to the model B, what will the population of the bison be in the park as time continues unbounded? Express your answer using limit notation. So this is part C. Limit as time goes to infinity. Time is continuing unbounded of B. So let's think about that. We have C over 1 plus AE to the negative BT. Okay? As time goes to infinity, this piece right here is going to 0 because it's a negative power. E to a negative huge number. That's like 1 over e to a huge power. And that thing is approaching 0. So we get that this is equal to just C. C over 1. C over 1 plus 0, which is just C. And C is equal to 4776.3405. So according to this model, there will only be one more bison born in the park, according to that model. That's the long-term behavior of the bison. Okay. All right, I'm going to leave that out because I need to go fix that on your sheets. Okie dokie. Next one I'm going to do with you is, this is the actual problem from the 2024 exam. Okay. On the initial day of sales, when time is 0 for a new video game, there were 40,000 units of the game sold that day. 91 days later, there were 76,000 units of the game sold that day. The number of units of the video game sold on a given day can be modeled by G. given by this function, where G is the number of units sold in thousands on day T since the initial day of sales. Part A. Use the given data to write two equations that can be used to find the values of A and B in the expression for G of T, and then find A and B. Okay, so part A, they tell us a value when time is 0, they tell us a value when time is 91, and we're putting 0 in for T, and then we're going to put 91 in for T, and that will give us two equations. Okay, so when time is 0, let's see if I can get all that up there. Almost, there we go. Okay, A plus B ln of 0 plus 1 must equal 40. Do not write 40, comma 0, 0, 0. 40 is the number of thousands of units. And remember, G is in thousands. So if you write 40,000, if you write that this is equal to 40,000, you're actually saying it's 40,000 thousand. That would be 40 million, and you don't want that. Just write 40. There's one equation. The next equation is when time is 91. We're putting 91 in for T. And there were 76,000 units of the game sold that day. So there are our two equations. Now we're going to solve them. Now, for the first problem, we were able to use our stat feature because the logistic function was given to us here. Okay, this equation is not one of these. It's not one of these, so we cannot use the stat feature on this problem. Okay, we need to be familiar with what these all give us. Okay, we need to know what a quadratic function would look like in this form, and a cubic function and a quartic function. We need to know those. If you do, then you can use those when possible. But we cannot use those here. We have to do this one by hand. Okay? So I'm going to start with this one because I like ln of 1. ln of 1 is just 0. So I'm going to start there. A plus B ln of 1 is equal to 40. ln of 1 is 0. So this gives me that A is 40. Now I go find B. I'm using this equation now, and I'm going to put 40 in for A. I'm going to subtract 40 on both sides and divide by ln of 92. So B will be 36 divided by ln of 92, natural log of 92. So 36 divided by ln of 92, 7.9614. Give at least 3 digits after the decimal point. Okay? Now, remember, we're writing this down, but we have to use the entire value. So I'm going to take that value, and I'm going to store. All I'm doing right now is I'm going to hit the store button. If you hit the store button, it takes the previous answer and it stores it in for whatever variable you say to store it in for. I'm going to store it in for B because it is representing B. So I'm going to store it in for B and then hit enter. Okay, now my calculator thinks that is B. I'm going to go to my y equals, clear out what's there, and then for y1, I'm going to put my equation for G. A, which was, we found it to be 40, plus B, ln of t plus 1, my x is going to be time. So now my calculator thinks that that is y1. Okay. So we're all lined up for success here. We've already gotten 2 points out of the possible 6. On to part B. Use the given data to find the average rate of change of the number of units of the video game sold in thousands per day from 0 to 91 days. Express your answer as a decimal approximation. Show the computations that lead to your answer. Change in the number of games over change in time from 0 to 91. So that's g of 91 minus g of 0 divided by 91 minus 0. The number of games in thousands at time 91 was 76. G of 0 is 40. So we have, I'm going to go to my home screen, we have 76 minus 40 divided by 91. So this time I did it without using the fraction template, by putting the numerator in parentheses. That's always an option if you don't want to use the fraction template in under F1. At least 3 digits after the decimal point are written, but we're going to use the entire in our next computation. Okay, got another point. On to part 2. Use the average rate of change to estimate the number of units sold on day 50. So we're using the average rate of change to estimate the number of units sold on day 50. So this is just what we did for the other one. So we're estimating G of 50. We're estimating G of 50. Using, now they didn't specifically tell us which to use. We can use either. So think about that. We have time, we found the average rate of change using day 0 and day 91. We can either start at day 0 and add to it, or we can start at day 91 and subtract from it. I think it makes more sense for me to start at day 0 and add to it. So we're starting at day 0 and we're adding the change per month, per day, times the number of days. And the number of days is 50. So on day 0 there were 40,000 sold. So let's find out what that is. 40,000 on day 1, day 0, plus the average rate of change times 50. Give at least 3 digits after the decimal point. Okay, part 3. Now we're going to let A sub I represent the number of units of the video game sold in thousands using the average rate of change found in part 1. For A sub 50 found in part 2, that was what we just found, it can be shown that A sub 50 is less than G of 50. Explain why, in general, A sub t is less than G of t for all t between 0 and 91. Remember, this part almost always deals with concavity. Let's go take a look at the curve. So it's stored in here. Let's think of a logical window. X is representing time, right? We're starting at time 0. I need to go at least to 91, maybe beyond, right? So I might go to 100. Maybe I'll go by tens. Okay, Y minimum, 0, makes sense. To how many do you think that they will sell? What would be the highest number that they would sell per day? Well, it needs to be at least 76, maybe more, right? I might go to 100 and go from there. Oops, start at 0. Go to 100. And maybe go by tens also. Let's see what that gives me. Okay. So that definitely does look like a logistic curve. Not logistic, a logarithmic curve. Okay. Here we are at time 0. Let's find out where we are at time 91. At time 91 there were 76, so I'm going to go find out where that, in fact, I can go ahead and put in 40,000 for day 1, or for time 0, and 76,000 for time 91. There we are. Oh, I should have gone a little bit past, let me go a little bit past that. I'm going to go, instead of having my X max at 100, I might make it 150. How about that? There we go. That's a little better. Okay. Sometimes we have to adjust our window as we're in here. So, think of the secant line between this point and that point. That secant line. There's the secant line. And they are saying they want us to examine times between 0 and 91. Why is the secant line giving us a less than the actual, or the predicted? That's what we want to say. It's all because of the concavity of this curve. This is concave down. So let's start with that. I know they want to see it. So the graph of G is concave down. And it's always concave down. I don't need to say specifically where it is. It is always concave down. Okay. The secant line between 0 and you can either put G of 0 or you could put 40 if you wanted to, and 91, G of 91, and there's, again, you could put, if you preferred 76 there, that's fine, doesn't matter. Okay, is below the graph of G on times between t equals 0 and t equals 91. Okay? Therefore, A of t is less than G of t on this interval. And that's why. Okay, part C. The makers of the video game reported that daily sales of the video game decreased each day after time 91. Explain why the error in the model G increases after time 91. Well, I'm going to go get rid of this 40 and 76. So there's the graph of G. But they say after time 91, after that time, sales start to decrease. Well, the model is increasing. Sales are decreasing. Therefore, the error will be increasing. The error between the model and the actual will be increasing. That's exactly what I'm going to say. G is increasing. after t equals 91. It's actually increasing always. If the actual number of games is decreasing, I might say after time 91, is decreasing after time equals 91, the error between the two between the model and the actual will increase. They were looking for us to use the fact that G is increasing. That's what they needed to see here. Okay, so that is a little look at these problems. Hopefully it won't take you as long to do them as it took for me to explain them. But I find these to be parts of these are really straightforward. Parts of them require a bit of thought. By the way, the global average was just 2 points out of the possible 6. So you don't have to get all 6 points to be doing, quote, well. Alright? So just get as many as you can get and don't sweat the rest. Also remember, on average, each of these should take you about 15 minutes. On average.